All right, we want to look at section 3.7, inverse functions. What are inverses of each other? They're things that undo each other, like adding to and subtracting to, multiplying by 5 and dividing by 5, squaring something and taking the square root. The idea is if you have x and you add to and you subtract to, it takes you back to what you started with. It takes you back to the x. So sometimes we can look at the function and we can say, okay, what's the inverse of multiplying x by 3? Well, that would be dividing x by 3. And so we can figure out the inverse just with common sense. This is the notation that we're going to use for inverse. So when you see them write this, you'll understand what they're referring to. So we see that here, they give me a function and then they give me that same notation and they say find the inverse. Sometimes it's not quite as obvious. And in that case, I can do two steps. Number one, I can switch x and y. And then number two, I can solve for y. All right, so let's try that. First off, I want to switch x and y, but I look at the equation and I don't even see a y. Well, is there anything in here that's the same thing as y? Yeah, f of x is the same thing as y, right? So if we first rewrite that so that we can see the y, now step number one, I can switch the x and the y. So that's what I've done right here, switch x and y. And then we need to solve for y. All right, if I'm trying to get y by itself, the first thing I'm going to do is get rid of dividing 2. So I'm going to multiply both sides by 2. Still trying to get this y right here by itself, so I'm going to get rid of this 5. So I'm going to subtract 5 from both sides. And then I would have negative 3 times y, so I would just divide both sides by negative 3. Now, this would be our inverse function. And there are quite a few different ways that we could write that. We could write it as what we just got. Or we could go through, since we have a negative 3 in the bottom, we could divide the numerator by a negative to get rid of that negative in the bottom. So that would give us this version. A lot of times you'll see them, they don't like to leave the leading coefficient negative, so they would reverse the order of that numerator. So the main thing is, if you're in a multiple choice setting and you come up with this as the answer and this is listed as the answer, I don't want you to think you've done something wrong. So we want to be sure we can recognize it in various forms. So any way we write it, that is our inverse. So if two functions are inverses, then if you do the composition f of g of x or the composition g of f of x, in either case, they should undo each other and take you back to what you started with. They should take you back to x. Now, we have done compositions before, so let's take the two functions we just had. So here's the f of x that we had right here, and then here's the g of x that we just created, where g of x is the inverse. That's what they're, you can see here, f of x and g of x are inverses. So it'd be the same thing as if we use this notation. Either way you want to go. All right, so if we're going to find f of g of x, remember we're going to start on the inside and replace g of x with what it's equal to. So there's the g of x function. So now we have f of the fraction. So f of the fraction says put the fraction in the place of x. So if I did that, if I put this fraction in the place of x, it would be 5 minus 3 times the fraction over 2. So 5 minus 3 times the fraction divided by 2. So one more time, if we're trying to find f of g of x, start on the inside. So we're going to replace g of x with what it's equal to. Now we have f of that fraction. So we're going to put the fraction in the place of x. So 5 minus 3 times the fraction over 2. 5 minus 3 times the fraction over 2. All right, so immediately we notice that these 3's will drop each other out. And so we're just left with 5 minus the quantity 5 minus 2x over 2. We're going to distribute that negative right there. So if we distribute that negative, we would have 5 minus 5 plus 2x. So of course 5 minus 5 will drop out, and that leaves us with just 2x over 2. The 2's would drop out, and we just get x. So if they are inverses, when you do that composition, they should undo each other, and you should just get x. All right, look at the reverse order. We need to now do g of f of x and make sure it gives us x. All right, so let's come down here and let's do g of f of x. So let's start with replace f of x with what it's equal to. So there's what we were told f of x is. So now I have g of the fraction. So that means put the fraction in the place of x. So that would be 5 minus 2 times the fraction over 3. 5 minus 2 times the fraction over 3. All right, so then we can start simplifying. We can see immediately these 2's will drop out. So that just leaves us with 5 minus the quantity of 5 minus 3x all over 3. And then we would want to distribute that negative. So when we distribute our negative, of course the 5's are going to cancel each other out. And that'll leave us with just 3x over 3. Make sure you have a positive 3x, because when you distribute that negative, negative 5 and a positive 3. So the 5's dropped out, and that gave us 3x over 3, where the 3's will drop out, and we'll just be left with x. So sure enough, f of x and g of x have to be inverses because we've proved it algebraically. We've proved that their compositions both lead to just x. Okay, so if that's an algebraic understanding of inverses, let's talk about a graphic understanding. Here's those same two functions that we were just working with. Here's the original, and here's the inverse. So that's what we were just using a second ago for g of x. So let's graph these and just kind of see the relationship between them. So I'm going to start off by making an XY chart for f of x. So I just picked values that would give us nice whole numbers instead of ugly fractions. So let's start with 1. If we plug 1 in, we're going to get 5 minus 3 times 1. So that'd be 5 minus 3. So 2 divided by 2 is going to give us 1. Then let's plug in negative 1. So negative 3 times negative 1 is going to give us positive 3. 5 plus 3 is 8. 8 divided by 2 is 4. And then let's plug in 3. So 3 times 3 is 9. 5 minus 9 is negative 4. Negative 4 divided by 2 is going to give us negative 2. And let's go plot those 3 ordered pairs. So we've got the 1, 1 right here. And then we've got negative 1, 4 right here, and 3, negative 2 right here. So that would be the graph of our original function. All right, so again, I've picked some values for x that will give us nice whole numbers instead of some ugly fractions. So let's start plugging those in. So if we plug in 1, we're going to get 5 minus 2 divided by 3. So that'll give us 3 divided by 3, which is 1. Plug in 4, and we would get 5 minus 8 divided by 3. So that's going to give us negative 3 divided by 3, or negative 1. And then plug in negative 2, and we'll get 5 plus 4. So 9 divided by 3 is going to give us 3. All right, so look at the ordered pairs that you have for the original and for the inverse. And what do you notice? So if you notice, xy over here is yx over here. So xy in your original will be yx in the inverse. If you have the point 3, negative 2 in the original, you'll have the point negative 2, 3 in the inverse. Because remember how we found the inverse. Step number 1, we switched x and y, right? Okay, so let's go ahead and plot those 3 points and graph our inverse. And so here's what we get for the graph of our inverse. And here's what you'll notice. Inverses reflect in the line y equals x. Okay, here's the line y equals x right here. That's one of our toolkit functions, right? Here's what they mean. If you were to draw the original function, which is in blue, if you were to draw that in wet paint, and then you folded it on this line, y is equal to x, it would transfer over and create this line that we see in red. All right, so they're going to reflect in the line y equals x. If I fold my piece of paper on this axis right here, this red piece will fold on top of this blue piece, and this red piece will fold up on top of this blue piece. So they reflect in that line. All right, so we have talked before about how we can tell if a function is one-to-one. Basically, if something is one-to-one, the function has an inverse that is also a function. And so the way that we checked this before was we said, first off, how do we figure out if something's a function or not? Well, it has to pass the vertical line test. And then how do we find out if its inverse is a function? Well, then it needs to pass the horizontal line test. And our reasoning for that is a function can have no two x values the same. That's why we do the vertical line test, to make sure there are no two x's the same. But with inverses, x and y switch places. So if I want to know if its inverse is a function, then I need no two y values the same. And so I would do a horizontal line test for that. All right, so simple way to put it, a function is one-to-one if it passes both the horizontal and the vertical line test. Okay, so if we look at this first parabola, all right, if we do the vertical line test, it passes the vertical line test, so we know it's a function. Does it also pass the horizontal line test? No. So that means it is not one-to-one. So it is a function, it's just not a one-to-one function. All right, look at the next one. So for the next one, for this line, does it pass the vertical line test? Well, yes, it passes the vertical line test. So what does that mean? It means it's a function. Does it also pass the horizontal line test? Yes. So if it also passes the horizontal line test, then it means it is a one-to-one function. Okay? All right, then the last thing that we want to talk about is, what if they want me to graph an inverse, but they don't give me an equation? All right, so, up here they gave me the equation. We could find the inverse and plot it this way. But what if they don't give me that equation, they just give me the graph? Okay, well, there are some of you that are visual enough that you can look at that and you can say, okay, if this is my original function, I'm just going to reflect it in this line, y is equal to x, and I will get this function. Like, you can just eyeball it and see that. But for those of us who can't, here's what you could do. Identify a couple of points on the original function, okay? So here's that original function. I'm going to pick a couple points, 0, 2, 2, 4, and 4, 5. So the point 0, 2 on the original, what will it be on the inverse? It would be 2, 0, because if the original is 0, 2, x and y switch places, so this point would be 2, 0. Same story here. If this is 2, 4, the inverse point would be 4, 2. If this is 4, 5, the inverse point would be 5, 4. So you can just plot as many points as you need to until you feel comfortable that you can sketch what that graph looks like. We could have done that up here as well. Instead of actually creating the XY chart, we could have taken the points on the blue original function that we had found and just switched them. So we wouldn't have actually had to plug these values in. We could have just switched them to plot them. So that's another option as well.